Have you ever stopped and wondered how a smart building actually works? You know, how all those different gadgets, the lights, the heating, the security systems, all play nice together? Well, today we're pulling back the curtain on KNX, which is basically the universal language that makes it all happen.
So, here's the big question, right? You've got dozens, maybe even hundreds of devices from all these different manufacturers. Without some kind of common ground, it would just be total chaos. So how on earth do they communicate with each other?
And the answer, pretty simply, is KNX. But here's the important part. KNX isn't a brand or a specific product you buy off the shelf. Think of it as a standardized protocol. It's an open language that any manufacturer can build into their products, guaranteeing that they can all talk to each other, no exceptions.
Okay, so here's how we're going to break this all down. We're going to start with the big picture, the communication blueprint. Then we'll get into the nitty-gritty, starting from the actual physical wires, moving up to how messages get routed, and finally we'll get to the brains of the operation where it all comes together. We'll also cover why this whole system is so powerful. So, how do you even begin to build a universal language for technology? Well, you don't start from scratch. You start with the proven, internationally recognized blueprint for communication.
KNX is really cleverly built on something called the OSI model. Now, you can just think of this as the universal rulebook for how networks are supposed to communicate. By adopting this structure, KNX makes sure that everything is logical, super robust, and really organized.
And here they are, the 7 layers. For this explainer, we're actually going to travel up the stack, starting at the bottom with the physical layer. We're going to see exactly how a simple command, like turn on the lights, makes its entire journey from start to finish. All right, let's get started at the very foundation, the actual physical hardware that connects everything in the first place. Layer 1 is all about the roads that the data travels on. And what's cool about KNX is how flexible it is. It can run on that classic green twisted pair cable you see everywhere. It can go wireless using radio frequency. It can even use the building's existing electrical wires through power line, or just hop on a standard computer network using IP. So if Layer 1 gives us the road, then Layer 2 is basically the traffic cop. Its whole job is to manage who gets to talk and when. And this is absolutely crucial, because you can't have all the devices shouting at once. This layer makes sure all the messages are sent and received in a really orderly way.
Okay, so our devices can now send data without bumping into each other. But how does a message actually find its way from, say, a sensor in the lobby all the way up to a light on the 10th floor? Well, that's where our next 2 layers come into play.
Layer 3 acts like the building's internal postal service. It is all about addressing and routing. It makes sure that a telegram, and that's the actual KNX term for a message packet, gets from its source to its final destination, even if that means crossing multiple routers and different parts of the network.
Now, inside every one of those telegrams is a really clever little feature. It's called a hop count. And when a message is first sent out, it usually starts with a value of around 6.
You see, every single time the message hops through a router on its journey, this counter goes down by 1. Why? Well, it's a brilliant safety mechanism. It prevents a lost or misaddressed message from getting stuck in an endless loop and creating a massive network traffic jam. Once that counter hits 0, the message is just gone. So the network layer gets the message to the right address. But the transport layer asks a different question. How should we send it? Think of it like choosing between sending a postcard, a regular letter, or a package that needs a signature. It offers different ways to communicate depending on how important the message is. And this flexibility is just key. For example, KNX can send a single message to a specific group of lights, or it can broadcast to every device in a line. It can even send a message in that tracked package style with delivery confirmation, which is perfect for critical things like firmware updates. It's all about picking the right tool for the job.
Okay, we've built the system's muscle and bone. We've got the physical connections and the delivery routes. Now let's move all the way to the top of the stack and find the brain, the part where all this raw data finally gets its meaning. But hang on a second. Where are layers 5 and 6? Surprise, they're empty. And that's completely on purpose. KNX brilliantly skips these layers to stay really lightweight and efficient. It's a fantastic less is more approach that's just perfect for the small, simple microprocessors you find inside everyday smart devices. And that brings us to the very top, Layer 7, the application layer. You know, all the work that the layers below did was just to deliver a package of data. This is the layer that actually opens the package and reads what's inside. It's the universal dictionary that defines what all that data actually means.
And that universal dictionary makes possible the single most important idea in KNX, interworking. It works because of a shared vocabulary of what are called data point types, or DPTs. So, for example, there's a DPT for on-off. You can think of it as a universal word that every single certified device is programmed to understand, no matter who made it.
And this right here, this is the answer to that question we asked at the very beginning. A light switch from manufacturer A sends out a command. An actuator controlling a light made by a totally different company, manufacturer B, receives it. Because both of those devices understand that same standardized data point type for on-off, the light just turns on. It simply works.
So here's a little peek at what this communication actually looks like on a KNX network. The second line there is a simple, easy-to-read command to turn something off. But that first line, that's a secure encrypted message. It shows you that KNX can easily handle both simple, everyday commands and highly protected, secure communication all on the very same network. So we've made the journey all the way through the 7 layers. Let's just zoom out for a second and talk about why this structured, layered approach is really the gold standard for building automation. The result of this layered model isn't just some clever piece of engineering. It's a system that is fundamentally robust. You get true interoperability, which means you're never locked into a single brand. You get incredible reliability because it's decentralized. If one light switch fails, it's not going to crash your heating system. It's totally scalable, growing from a single room to a massive skyscraper. And its flexibility makes it basically future-proof, ready for whatever new tech comes along. This whole system, this standardized language, has really allowed our buildings to become truly interconnected for the first time. And it brings up a pretty fascinating final question. Now that all these different parts of a building can finally speak to each other, what new conversations, what new efficiencies, and what kind of intelligence will we see in the smart buildings of tomorrow?